Hi everyone, my name is Szymon, and today I will be talking about the Scala Toolkit, how it makes Scala batteries included, and what was the process that we employed in creation of the Scala Toolkit. But let me start with an introduction of myself. So who am I? I work at the Scala compiler team at VirtusLab, closely with teams at LAMP and the Scala Center, and I also contribute to the Scala compiler regularly. As I said, the Scala Toolkit project. I'm coordinating this project, and I will be talking about this project today. So I want to start with a question I have for you. So what do you do when you start a new Scala project? I think the usual answer would be that you create some build file for the build tool of choosing. You choose some libraries, and then you create some sources, and then you're able to run it. But each step of this process takes some effort, takes some time, and requires some context and knowledge. And if you're wanting to write a simple prototype, or if you're wanting to script, it may be a bit unpleasant and inconvenient to work with. And especially it's the case if you put yourself in the shoes of a newcomer to Scala. Because if you want to use a build tool, you have to know which build tool you want to use, and you have to know some basics of it. And then if you want to solve a problem, write some program, then you have to know what libraries do you like. And it's often the case that people get recommended with some libraries from their colleagues, or they Google some libraries, and the libraries they found are forcing them to know some advanced, intricate language concepts, like higher-counted types or some kinds of abstraction. And so the newcomers and the people that want to write the prototypes or scripts are faced with this problem. And that's where the Scala Toolkit comes to the rescue. So it's a project by Scala Center and VirtusLab that we are currently carrying out. And in its essence, it's a set of battle-tested libraries from the community. So these are not the libraries that we created. These are libraries that are already popular in the Scala community and tested. We just selected them and made some effort with the maintainers into integrating them. It is published as Toolkit and Toolkit the test in the Scala organization. There are two artifacts because one is for main scope and one is for the test scope. It's very important to us that it works on all the platforms that Scala supports. So it works on JVM, Scala.js, native, with some simple exception of working on processes, because it's hard on Scala.js. It's also integrated with Scala CLI and SBT, so everyone that wants to use the toolkit can have like the smoothest and simplest experience when doing so. So yeah, exactly. In its essence, the Scala Toolkit is meant to be a kind of an extension of a Scala standard library that people can default to. And it's not a de facto standard library, but we want to put it as close to the users of the tools in Scala as possible. So if you have Scala CLI, you can just put using directive on top, using toolkit with a version. You can also put latest in there, and that will fetch the latest version for you. You can write your code, run it, and that's it. So instead of the process I told you before, now you can just install one program, Scala CLI, write one short line of configuration, and you have this problem solved for you. You don't have to think about the libraries, and a newcomer can just do that, and that's everything there is to it, basically. If you want to create an executable script, you can just use the shebang feature from the Scala CLI. That would be the Scala script that you can put in your CI, and I think it's actually pretty convenient. Aside from these integrations, we also created a set of Q&A like simple short tutorials that if you have a simple problem that you want to solve, such as making an HTTP request, downloading a file, or anything like this, you will find them via, for example, Google. You can go there, and it's kind of similar to the answers you get on the Stack Overflow, but it's like more consistent in structure and hopefully welcoming to newcomers that want to approach some problem that they want to learn Scala with. It also features IDE support via Scala CLI. If you have selected like an older version of a toolkit, you'll get a suggestion to update it. You'll of course always get the suggestions for the libraries and navigation, because it's just a dependency that's seen from the Scala CLI, and it also has an integration with the template command, the SBT new command in the SBT. So if you want to create a project with the Scala Toolkit, you just go write SBT new, hit enter, and you have a project with the Scala Toolkit inside of it. For testing, there is an additional artifact, as I said. There is the toolkit test that Scala CLI will automatically add to the test scope. And this is the same for SBT as it will be added with the SBT configuration. The problems that we solved so far with the toolkit is the HTTP client, the JSON parsing and writing, operating on files and processes, and testing. These problems were solved with a set of libraries from various ecosystems. From software mill, we have STTP, we have UPCL and OSLI from Lihaoi, and for testing, we have the MUnit from Scala Meta. We want to solve even more problems. We for sure want to have an HTTP server and a database client and a CSV library, but there will also more of them later added on. There can be also other toolkits. There's already a type-level toolkit created that you can use in a very similar manner to the Scala toolkit. You just use this directive, and you're good to go with a set of basic libraries from the type-level ecosystem. And when creating the toolkit, our priority was to directly address the problems of the target users. So we wanted to have a good developer experience. We wanted it to be easy to set up and work with. We wanted to provide a set of tutorials that everybody knows how to do everything in the toolkit, and we wanted to make sure that these libraries work together. And that's when I want to stop for a moment and go back to the process, because this may seem simple, but they are actually a bit hard to approach, especially, for example, the first one. What does a good developer experience mean? And we wanted to approach it all like a technical problem. So first, we wanted to do some research and get to know the problem, the essence of the problem. So the first step was a qualitative survey we did on the developers of Scala from different backgrounds. It included both experienced developers and newcomers, and also teachers from the Scala community. And also we did some analysis of the ecosystem. And we heard things like this. Those are the quotations from these people. We heard that some of them find the setup hard, and that's what's sometimes stopping them from getting into Scala and more easily. We heard that from even experienced Scala developers that there are a lot of very short but hard solutions, and sometimes they would want a more simple one. And one teacher told us that when the story where his students, when he tasked them with homework, they were finding some old solutions, and then he had to explain to them himself how to solve the problems and providing them with more recent, up-to-date ones. They also sometimes feel that the Scala is designed to build big projects. And I personally think that it's a problem, because when a language has a feeling of it, like it's designed to build big projects, then it's hard to get into it. Because when you get into a language and when you learn it, then you have to create small projects. You start with small projects, some small programs. And it's also a big part of the market, writing the scripts, writing POCs, the prototype microservices. I think that we don't want to lose that part of the of the ecosystem. So, and the other person was lost in the Scala ecosystem because they were Googling the libraries and they couldn't find the right one and couldn't know which one should they choose. And once again, there is one more problem with everything that I was saying. I used the word simple a couple of times, and it's a very bad word. I shouldn't use it. And why is it a bad word? Because it's very hard to define it. It has a lot of meaning. A lot of people are using it. This word is used very often in context of when people reason about design of libraries, design of APIs, of languages. But you have to, if you want to create something that's simple, you have to think about it a bit more, because it's not an objective trait. It always needs context. Something may be simple for example, in one problem or for one person, but not for the other. And it's also a very broad concept. So actually, I think that it doesn't have a clear meaning. It could either mean that somebody doesn't get tired when solving some problem, so it's simple, or maybe he spends a little time on that, or maybe he doesn't make any errors. What does simple even mean? So first, the context. We want to know the problem that we solve if we want to declare something as simple, and we want to know what person might consider it as simple. So for Toolkit, these are the two greenfield projects, the POCs and microservices, and scripts. So the only area that's left out, I think, are the big enterprise projects that are not left out on purpose that we are actively making Toolkit unusable for these projects. No, it's like we don't focus that much on them, but it may be useful for these projects as well. And the people that we want to approach with Toolkit, this is basically everyone. So it doesn't help us much, but we think especially about experienced developers, the newcomers, and students of a teacher. So we want to help the students and teachers as well and think about that too. And for the definition of what is simple, what do we exactly mean by the notion of simplicity, we decided to just throw the word simple in the trash. And I think that was a good idea. Instead, we use the cognitive load. And it's a better word because it's defined in some academia areas. And there is some research on that, there are papers on that, there are ways to measure that even. So that's what we went for. And we try to derive these measures from the cognitive load. But let's have a short introduction to the cognitive load first, so you know what I'm speaking about. I think the essence of it, I won't go through the details, that's an very oversimplified version, but in general, the cognitive load is the amount of information you process in your working memory. And that's the main limitation during the code comprehension. So when you have a lot of variables in your method, or where you have a lot of context, a lot of side effects out of global states, that's an example of a frame of thought when you can reason that a global state is bad. It's because you have to keep it in your mind. It increases the complexity and the amount of stuff you have to think when comprehending code. So therefore, it hires the cognitive load and one could say that it makes code less simple. So as I said, good thing about the cognitive load is that it's kind of measurable. Why kind of? Because we can't do that to Scala developers. That would be expensive and hard. We can't put them in MRIs and scan their brains, because that's where people were doing in these papers that I read, that you actually can have a person put them in an MRI and fMRI actually, and basically see the oxygen level, the blood oxygen level are in the different areas of the brain. And if you know that some area of the brain corresponds to the working memory, you can actually approximate the cognitive loads of a person. It's not directly that variable, but it's correlated with the cognitive load. So it's, as I said, the cognitive load is better than simplicity because it's measurable, but measuring directly and empirically is very expensive and also methodologically challenging, so we didn't think of that. We weren't doing that. But instead, we thought that it could be a good idea to read these studies, learn what they learned, and maybe also some older studies when they're reasoning about the cognitive process, and derive some heuristics from that we can look at the libraries as a team and try to apply these measures to. And that's where the cognitive dimensions come. It's a framework that is used to do exactly that. It can assess the cognitive load of a given code. It was used in past. At first, it was used to assess the cognitive load for language design. Then it was adapted for a .NET platform in Microsoft, so they use it in the development of .NET platform. And most importantly, after that, it was used in Scala Toolkit. So we adapted our own set of cognitive dimensions. There are quite a handful of them, and I won't be going through all of them. I can explain them to you afterwards if you want to reach out to me, or even at the conference. But in general, they are meant to measure somewhat orthogonal components of a cognitive load of an API. There are 7 of them. And they're as simple as possible in the way of measuring, because they can be either true or false. And they have to be true, like this property that the cognitive dimension describes. So when you measure, we have one question about the code using the library. And if this question is true for all the scenarios where the library is used, then it's true for the library. And then we can rate these libraries and then maybe even work on them to make their score higher and reason about them, because it also gives us a frame of thought, frame of thinking about the usability of these libraries. As an example of a cognitive measure, I can show you the abstraction level. I think it's one of the more interesting ones, and you have to ask yourself 2 questions, and you want to measure if the abstraction level is correct from the cognitive level perspective. You have to think what your user, what the abstraction level that your target user thinks on. And then you have to think whether the code that is written using this library is on this level of abstraction. So for example, that would not be the case for Toolkit. If you created a library for reading files that used higher candidate types, that's not what we would put in the Toolkit. It requires additional cognitive load because somebody has to understand the notion of higher candidate types. They have to understand what abstraction of the execution is. And even the number of symbols in the code is higher. What we would go for instead is just a simple method. That's what we want in Toolkit. That's exactly what we want in Toolkit. In general, it's because the abstraction has a cost. That in general, introducing abstraction therefore should be based on the analysis of the cost and the benefits of introducing it. And you usually can have growth of the complexity when you introduce some abstraction in your code. It can also be, of course, beneficial. You can have more general code. You can be more productive in abstract code, but it can also higher the entry barrier for your project. You will need to put more resources towards teaching of your developers and also towards the onboarding on the project. So like going into a bit more of the detail, like if you wanted to reason about the abstraction from the cognitive load, we could think that from the long-term memory perspective, and long-term memory is your knowledge, what you know, what you have learned, you have to have a practical understanding of that abstraction. And that's not the case from most developers coming from other languages than Scala. It's my personal experience, but when I talk with Kotlin developers, for example, they don't have any understanding of this concept of abstraction over the execution as you've seen in the file reader. And it's not like I can explain it to them. I can explain it to them, but they then don't have the practical understanding of it, so they have to spend some time working with that abstraction. It just introduces a lot of cost. So we decided to not do that in the toolkit. And for the working memory, it even always involves some additional context that you have to keep in mind. If you're adding 2 integers, then you're just adding integers. But if you're operating on I/O of 2 integers, then it's additional cognitive load that we don't want in the toolkit. So in general, clever abstraction is cool, but we thought in the toolkit that we should concentrate on the purpose of this abstraction and the consequences of it. After all this consideration, we put these cognitive dimensions to work. And first we chose the libraries, and then we even worked on the libraries that we've chosen. Adrian from Scala Center made a change to the STTP library and created new simpler client that got rid of this abstraction that I was talking about. And I'm also working on other usability fixes here for like OS sleep, but there are a lot of things that we want to do in the libraries in the toolkit, both from the perspective of usability, that we can reason about thanks to the cognitive dimensions, and the stability of these libraries, because we found some bugs in them, so it's a simple process. So in summary, we use the property of cognitive load instead of simplicity, and we found it more useful. Then we measured these cognitive loads with cognitive dimensions, and this cognitive load, the mismeasured cognitive load, was then used to choose and adapt the libraries that we chose for the toolkit. But these are not the only priorities we had with the toolkit. Because the simplicity and usability is one thing, but also it's very important that the libraries are stable, so we wanted to make sure that tests are there and their coverage is high, that the maintainers are available and responsive, because we could have a problem with maintaining these libraries all ourselves. We wanted the documentation to be good. The libraries already had to be popular, so even if we found some very usable library, I think we don't trust our process that much. We just wanted to have another factor. Like if a library is popular already, then we know that some people like it. And if it's usable and simple as well, then we chose it. We wanted to have a small size. The API should be stable, so over 1.0 version in Semver. Dependencies had to be of a low number and a small size. The dependencies also had to be stable. The versioning had to be done with Semver for all the libraries, and the libraries had to be cross-platform and work on all the platforms, aside from the one exception I told you about. And after we chose the libraries, there was another problem that we found, because how do you put unrelated libraries together and ship them? At first, it, again, may seem like a simple problem, but the more you think about it, you find that, for example, how do you version them? How do you make sure they're compatible with each other and that they're compatible with the version of the Scala that the user uses? And especially, how do you make sure that with like this little oversight of these libraries, because it's actually we're not maintaining these libraries, we are not releasing them, like the main people responsible for the libraries are their maintainers. So we have to make sure that no unexpected changes are made to the libraries and nothing is broken and nothing is incompatible. And we also had to make sure that they are secure, that we know how to take care of any security vulnerabilities that may happen. So as a first problem, the versioning, we handled that with a Semver, and API of each library that's included in the toolkit is treated as a public API of toolkit. So if any library gets updated, has a version updated, any change that's, for example, non-forward compatible or anything like this, then we'll bump the version of the toolkit. And the transitive dependencies also count. So all the dependencies in the toolkit are the public API of the toolkit in the terms of versioning and compatibility. And we are validating all that with a custom CI script that is run on the whole dependency tree on the toolkit. Why it's run on the whole tree, not a flattened one? Because different build tools resolve dependencies differently. So we really don't want to have any difference because somebody may be using Maven or anything like this, or might have a custom logic to that. So we run on the whole dependency tree. If anywhere in the dependency tree, even if a library is duplicated, there is a change, then we have to address it with versioning of the toolkit. And yeah. we make sure of all of that with a changelog that is generated both for the user and for us. It gives us insight into what's happening on with the toolkit. And for each version, for each release, and for each platform, we know about all the changes in the direct dependencies and in transitive dependencies. And everybody can look at that and see the full dependency tree of the toolkit. And for the compatibility, it's just that every library must work on the Scala LTS. And we give a guarantee that as long as a given LTS is supported, the toolkit for this LTS, so the current LTS is Scala 3.3, will also stay supported. And even if there is like a new LTS, we'll be providing patches to the old libraries, so it's safe to use toolkit with the version, with the LTS for liking. And for the security, why it's so important? Because if we say that there is this toolkit project by Scala Center and VirtusLab, we are kind of putting some promise to it. We are telling you that it's safe and stable and secure. So we decided it's important that we have plans for different kind of security vulnerabilities, and we created these plans. And we also have plans for maintenance unavailability. Yeah, when they are not unavailable. Yeah, I'm speaking a lot. So in that case, we will just release, just fork the library, release it on Maven, and replace it in the toolkit. Not that hard of a problem. Some people were thinking that it would be hard, but with this approach, that the toolkit is just an artifact on Maven, it's actually pretty simple. And I would like to encourage you to be part of the toolkit, and you can do that by creating issues with proposals in the Scala Toolkit GitHub repo. You can take part in the discussions on Discord and the contributors thread. There is a new, on the Scala Discord, there's a new channel that's exactly for the toolkit, and yeah, it was created like a few days ago, so if you want to discuss something, then yeah, it's a great place for that. And you can also come to our booth, the Scala Space booth, or directly to me and discuss everything that I was talking about, or maybe some suggestions, anything. For the near future, we want to release the version 1.0 of the toolkit. It will have more libraries, and we'll have usability fixes built based on the cognitive measures I spoke about. And after that, we still want to grow the collection of libraries, evolve the process I was speaking about, and also change the usability and improve the usability of the libraries that are already there, and also add more integrations between these libraries. And I would like to finish with a quote that no, it's not a quote, it's a quote from me, it's my opinion. So I'd like to finish with an opinion, that's my opinion. And I recently started using Scala for scripting, and I feel that it's actually an excellent choice right now. Given the Scala Toolkit, given the Scala CLI, especially the Scala CLI is a great tool. And if you're writing scripts in Python or anything like this, if you have a need for that in your CI on any other place, then I highly encourage you to try out the Scala for that. I think you won't be disappointed in that. And as a last thing, I would like to remind you about the Scala survey. If you didn't fill it out, I would really like to ask you for that, because it really helps us to know what do you use, what are your problems, and basically we have to know the context to work on the Scala compilers, Scala libraries, and such. But yeah, thank you for your attention, and I would like to hear your questions.